Good evening. Good evening. You are welcome to our today's tutorial. Today we'll take a look at chemistry. Today we'll take a look at chemistry. Okay, so we are still treating kinetic what, theory of what, matter and what, gas law. This is the broad topic we are still on. Are we together? So we treated kinetic theory of matter. Now we are treating what, gas laws. I can remember we treated Boyle's law, right? We also treated Charles' law. I think we stopped at ideal gas what? Ideal gas equation, right? Okay, general gas equation. Okay, I agree with you. General gas what? Equation. That's where we stop. Thank you. General gas what? Equation. So if I give you question now on Boyle's law, Charles' law. Okay, we also talked about pressure law, right? Good. If I give you question now on Boyle's law, Charles' law, pressure law, general gas equation, you can solve it comfortably. We were about entering, picking questions from jam passes, but we couldn't, right? Did we? Okay, just one question, right? Hope we can solve question on that. Okay, let me test us again before I can beat my chest and say yes, you can. Because I plan to enter Dalton's law of partial pressure and see how we can go with it. Then enter Heidegger's what equation, then probably Gelushak's what law. But let me see if truly you can solve questions on those ones with if you if you are able to prove to me that you can, then I'll move on. It's only one person that I've been speaking with confidence. The others are still doing their head like this, as if they are not yet sure. Especially Jude. Jude is not sure. All right. So let's pick some question here and see how far we can go. I'm going to take some question. When I'm done, China, you come and write them on the board for us. Okay? From this past question paper. Please be fast about that. I thought I came out. Okay. Please, okay? Be fast about that, please. So we don't waste time. Okay. 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 Okay, come and write this one first. When you are done, write this one first. Where is it again? Write this one first. This number is after. Don't forget to write the year. Okay. This is 1987. You know how I've been writing it now. Write out this one first. Let me look for another one. Sorry. Fast.
Going to put this in here.
I need to. I need to sometimes to go off. Once this thing goes off now, you don't hear anything again. What we're looking at, so I know when it goes off, so I can get them now. Why they come late to this? Why they come late to class? Did the one and he came late. Only cancel came on time today. Bravo, cancel. Hold on now. Remember, you are want to solve this one. I want to test whether you truly grabbed. We are going to write out 4 questions. You solve them one after the other. So, I want you to prove to me that you have mastered them before we move to another one. Then go back. Go to go to this one is from which heading? Huh? Is it from boys law? Then go to child's law, pick another question there. Write it out. Let's see. Fast. Anyone you pick, you tick it. Take pen. Pick a question. I think pressure. Is there any question on that pressure law? Only one question is there. Okay, go to Jeragas equation. Anyone there? Is there any question there? Huh? Write it out. Just choose any question then. Just tick the one you choose. When you are done, you go to kinetic theory of matter proper. Then choose one question there. That's all. That's four questions. Please, I want us to be fast about that so we can move on. Okay, so let's use this question here to actually know how far with what we've grabbed in this topic. Okay, so let's use these questions here to know what we've grabbed. The first question says from JAM question 1987 question 5. It says if the amount of oxygen occupying 2.76 liter container at a pressure of 0.825 atmosphere and 300 Kelvin is reduced by one half, what is the pressure exerted by the remaining gas? If the quantity of oxygen occupying a 2.76 liter container at a pressure of 0.825 atmosphere and 300 Kelvin temperature is reduced by one half, what is the pressure exerted by remaining gas? Who has solved it? So what did he do? Tell us what he did. Just tell us what you did, okay? 0. What? First of all, what law do you think we can use to solve this? Huh? Which law? Boy's law. Okay, what parameters are therein that make you to think so? What parameters are here? Only what? Volume and pressure. Okay, I agree with you. I continue.
0.825 times 2.78, 2.76. Then it told us that at a pressure of 0.825 atom and 300 it's reduced by one half. That I divided it by that 2.76 divided by 2. So I made it my V2.
You have V2 is what?
1.38 liters.
How did you interpret this one half? What? China, you are sick up in share? Did you solve it? You did not. Huh? Council, did you solve it? Wow. How can I move to another question when this is still not clear? Another topic. What do I do about this now? If the quantity of oxygen occupying a 2.76 liter container at a pressure of what? 0.825 atmosphere and the 300 Kelvin temperature is reduced by one half. What is reduced? What is reduced? The what? Temperature. Is it temperature that is reduced? What parameter was reduced here? What quantity was reduced here? Volume. By what? One half. What is one half? What is one half?
When you divide it,
One half.
a part in one.
One half is easy. One half is it something with half? Which year is this? Which year? 1987. One half is it something with half? Huh?
One half is something.
Are you sure? One half. Check it. Some of these old questions. Let me not talk much. There's some funny words they use that if you start comparing it with what's going on now, it may not actually tally. But let's just see what we hear. What is one half? Is it half or what are half? That's a big question. You need to ask yourself first before you can answer this question. If you don't know the meaning of one half, you can never solve this question. Is one half half or is it one and a half? Don't you have data? Eh? Check it now. Okay, don't have network. Okay. Uh-huh. What is one half? Find out what let's find out what one half is. Is it what? One what? One what? Is it what? Okay. You that is network mama. What's going on? You that is what's going on? Okay, let me see what you have. Let me see what you have. One house, specifically refers to fraction is half, okay? We represent one part out of two equal parts. That's why I ask you, that's why I ask which year did I ask this question? This is 1987, okay? So it's expected. Am I communicating? Am I communicating? Good. Now, if one half is half, so what does it imply? The quantity of oxygen, if the quantity of oxygen occupying 2.76 liter container is reduced by what? Half, one half. So what now is the new volume? Which is what? 1 point what? 1.3. Are you following? Is it 1.38? Yeah, it is. Yes, it is 1 point what? 38. So that means P1 is what now? 0.825. Then V1 is what? 2.76 liters. Then VP2 is what you are looking for, right? Right? So now, Boyce will state that P1 V1 is equal to what? Boyce will state what? That what? P1 V1 is equal to what? Are you sure we are all following? Are we following? Good. So P1 is equal P1 V1 is equal to what? P2 V2. But what are we looking for? We are looking for what? P what? P what? 2. So let's make, if you make the P2 the subject of the formula, it becomes what? P1 V1 over what? Over what? Over what? Huh? No, answer. Over what? V2. Good. Over what? V2. So if that is the case, sorry, okay, let me come over here. I'll try. I don't want to. I don't want to clean anything here, so we can solve these ones. That's why I'm looking for space there. So we can solve it anyway. So if you continue from here, P2 is now what? P1 is what? P1 is what? It's only someone, one person that is active here, and I'm not comfortable with it. That's why I'm throwing this question on this side. Please, let's be active in this class, okay? Please. P2 is what? 0. What? 825 atmosphere, right? Times V1 is what? 2. What? 76 what? Liters. Over what? Over what? 1 point what? 38 liters. Have you seen why I said that JAM doesn't need calculator? You know, you don't need calculator to solve JAM question. Simply cancel what? Liter will do what? Cancel liter. This is only half of these, two of us. So this divide this is what? Is what? 1 point what? 38. Two of us. Is it 1.38? Or 2? Which one? Is 2. Is what? 2. Right? It's 2. This is double of this, so it's 2. It's not 2. What is that? I'm here trying to explain something. You are pointing somewhere. And you're not following the one. When we are done here, you face it and start pointing this one. Your eyes should be where we are now.
That 1.3 is one half of this 2.7.
Yes, now. So if this is half of this, so if you divide it by this, it to give you what? 2. True of us. So multiply this by 2. If you multiply this by 2, you get the answer.
How do you get 1.8 from that distance?
How do I get what? Is it clear now? So here now, 0.825 times 2. What will they give you? 0.85 should give you 1 point what? 1.65. 1.6. 1.6. You punch your calculator. Hey, please, can we keep that thing? Just keep it. Try, please. This is that the same training we are talking about. Drop it. This is 1 point what? 65 what? Atmosphere. So look at the option. What's the answer? What's the answer? A. They left it in 3 what? Decimal places. The answer is what? 1.650 what? Atmosphere. Is it clear? Any confusion here? No confusion. So, is that what you got? So only one person got it here. Is that what you got? You. How do we move? How do we move like this now? We can't remain in one question, in one topic forever. I think we need to move on. Is there any challenge you have in this topic? Let me know. So why couldn't you solve this one? Remember, if you watch, sometimes they will not tell you that temperature is constant. It's kept at what? 300 what? Kelvin. If you're not careful, if you don't know what it means for temperature to remain constant, you'll be battling with this 300 Kelvin. And I think that's what most of you are battling with. Let me see your work. You are battling with that 300 Kelvin. Okay? Let me see your work.
I just solve number 2 first. Still trying to solve number 1.
You had to get 276 from. You using Charles law to solve Boy's law.
No, this one is number 2.
Number what? Okay, you left number 1. You did number 1. You ran away from it. And let me see what you did. Let me see your work. Let me see it now. What did you do? I mean number 1. Where you saw number 1. You also ran away from it. I said it. This one minute is battling with. You see a back. Wait. Where's number 1 now? You use number 1. You also ran away from it. Okay, they ran away from number 1. So then you solve it. Let me see what you. So only one person solved this. This is not good though. I don't think it's good. It's not good at all. No, it's not. Do you have any issue with this thing? So what's going on? There's something what's going on here. Something you don't have issues with. You couldn't solve it. Then something's not solved. Three of us. So what is that? What is that thing that is wrong? Please let me know. I want to hear from you. What is wrong? What is it? What is it the issue? Tell me the issue. Let me know. Tell me.
This one have
Okay, the have confused you. But you don't know what have means now. That's what I said. That if you don't know the meaning of that have, that is an old question. So they can be using some funny. Remember what you wrote in biology? That question of 1979 or 78. They were classifying what is it called? Fungi as what? Plants. True of us. Fungi as what? Plants. That was before the five kingdom words came up, okay? But now you cannot say that for now fungi is on their own words kingdom. Am I communicating? You don't call them, put them under plant again. Am I communicating? Good. So let's continue. So now let's look at who solved number two. So what
That one half. I want to know how it
how I got what?
got. That one. That one half from that to 23. That one down.
What do you understand by one half?
The face, like um, a part in
So what does it mean? So what does it mean? Hmm?
okay,
What does it mean? That's the question. Sim, okay.
a, a part in
What does it mean? In a layman understand, what does it mean? Tell me.
half of
Half of it, right?
a
So you're not asking how I got half of
yeah.
2.76. Divided by 2 now, right? Get the answer. Is it clear now? Okay. Question number 2. So can you tell us what you did in that number 2?
I used house
Charles law. So what informed your decision to use Charles law? Tell us.
because the pressure remains constant.
Pressure remain constant. Okay.
Find the volume.
The volume.
As
Okay.
if the pressure remains constant, I use V1 over T1
Okay.
equals to V2 over T2.
Okay.
So 92 over 276. That's
Okay. Wait. Because let me be writing while you. So I can clean here now, right? I can clean this question one, right? Okay. Okay. So you said what? Solution. And what do you say, Jamsi?
V1
V1 is what? Uh-huh.
over T1 equals to V2 over T2.
Uh-huh.
92 over
Please, even though this is not a theory, there's no essay question, but try to list out your parameters so you don't get confused along the line. Okay? List which is V1, which is what? V2. So V1 is what from the question? 92 what? 92 what?
CMQ.
92 CMQ. I agree with you. Uh-huh.
T2 is 3
T2.
T1
T1 is what?
3 degrees Celsius
Plus what?
7
Which is what? 2 what? 76 what? Huh? 276 what? Kelvin, good. Okay. What next? V2 is what? We don't know, right? What next? T2 is what? 18 plus what? Where's the 18? Okay, I agree with you. 273 equal to what? 219. 291. 291 what? Kelvin. Okay, what next? So, oh yeah. How can you substitute without making such a formula? Uh-huh. V2 is now equal to what? Hey, is what? Make V2 the subject of the formula here. Oh yeah. V2 is now what? V1 over what? T1, uh-huh. Can you make, do you know how to do it? Do you know how to make subject formula? That's the question. Yes or no? You don't know how to make that is the issue now. This is the issue now. To make this in subject of the formula is the issue. I want to find out where your issue lies so I can know how to help you. That's why I'm asking this question. I'm not flogging you or doing anything. I want to know so I'll know where to help you. Look at it now. That is the issue now. Subject of what? Formula. You want to make V2. Listen carefully. If you have something like this is a proportion. Okay? This is a ratio. This is a ratio. Two of them combined like this is a proportion. If you want to make any of them the subject of the formula, you cross multiply. This will multiply this, equal, and this will do what? Multiply this. So if you cross multiply, you have something like this. V1 will multiply what? T what? 2 times what? T2 will be equal to what? V2 times what? Times what? T1. So what do we want to make the subject of the formula? V2. If we want to make this V2 the subject of the formula, what it means that we want this V2 to be on its own, right? That means right? That means we divide both sides by what? Huh? Are you going to Montauban? Please, I don't want it here. Do you understand what I'm saying? I want you to learn this now. That's why I'm doing this. I'm taking it down to JS1 now because I want you to learn this thing now. It's an issue. And if you don't know it, you keep having issues in your calculations. Am I communicating? So I said this is what we want this one to make this V2 the subject of the formula. By so doing, we want it to be on its own. This side on its own. So what do? We divide both sides by what? By T1, so that this T1 can leave it. So that if you cancel, this T1 will go. Of course, that's for what? V2. That's what we need to divide both sides by what? Divide this side by T1. Divide this side by what? T1. Okay? So that means T1 will do what? Cancel what? T1. Look at me. Be coming to math class. This is one of the reasons why I advise, even if you're not writing JAMB, you're not writing maths in JAMB, I advise you to be coming for your maths class. Don't say, I will not write maths in JAMB. Be coming for your maths what? Class. It's very important. There is application of mathematics in that physics you think you want to write. You know, there are some concepts they will not teach you in physics. There's no topic like change of what. Then there's no topic like that. What we see is application. True of us. But if you don't know this change of subject as a topic in mathematics, you cannot. If you get this place, you become confused. True of us. You get lost. That's why I say, be come to mathematics. Saturday, go to mathematics class. Don't say, I will not write maths in JAMB. Come. Okay, so you now know, understand what to do here, right? We cancel this and do what? This. They will go, right? What you mean is what? V2. Are we together? So V2 is now what? You keep realizing it only your man. Is now what? V2 is now what? V1 times what? Answer me. Times what? T2 over what? T1. Do you now understand how we got it? Change of subject of what? Formula. So we can now substitute the values now. From this parameter we listed, V1 is what? 92 what? cm cube. Times T2 is what? 2 what? 76 Kelvin. All over what? Unna from there. T1 is what? T2 is what? 291 watts Kelvin. Over T1 is what? 2 watts, 76 Kelvin. Look at these things. Do you think anything can cancel? Will cancel. Look at it critically. Look at it. Yeah, of course, Kevin will go. I agree with you. Kevin will go. Kevin will go. Look at it critically before you punch that calculator. Look at it. What do you think can how do you think we can solve this without carrying a calculator? Did they allow you to use calculator in Jam?
It's calculated.
There's a calculator there. Okay, you punch in calculator.
Yes.
Wow. Okay, they've changed it. Okay. What if he disappoints you? No, what if that thing you want to punch disappoint you? Yeah, man. Okay. He can't disappoint you. Wow, that's good. That's good. Nice one. Amen. Oh yeah. Thank you. In my class, look at it. Oh yeah. Hey. Chineke, what are you saying? Chineke, become to mathematics class. How can you cancel two here? Cancel two here. Who does that? Can you stop? Please stop. Who can tell me what you can do here? 92 into 3 is what? 92 times 3 is what? 27 what? 27 what? You don't need a calculator in jam. You don't need it. They'll give you numbers that you can solve without punching calculator. You don't need it. 92 divide 276 is what? 3. 3. Simple. Can look at this. 291.
Sir, wait. How come 920? No, it's not like
It's not 22. It's not 26. It's not. Look at it. This is CMQ. Look at it. No. Is it now? It was listed here. That's 2. Now, can 3 divide 29? Says who?
yes.
You can comfortably. Look at it now. 3 divide 29. We give you what? Now remember what? 2. You bring out 9. 2 times the base you're working on. 2 times 10 is what? 20. Plus this one here becomes what? 21. 21 divided by 3 is what? 97. We don't need to calculator. The answer is what? 97. You don't need calculator. I keep saying this. People don't understand it. WEC doesn't choose their what numbers like that because they know they allow you to use what calculator. They don't choose, but jams carefully select their figures so you can solve without what punching calculator. The issue is this: do you know your numbers well? How do you play with numbers? That is the issue. So the answer is what? 97.0 what CMQ. Who got this answer? How? What magic did you do when you're battling with making V2 is sort of formula?
I just carried it over like that.
She was here battling with what? Such a formula. So I wonder how you got that. So you did what to other biology?
No, I just,
You do to
I solved it like this. I just introduced.
There's no way you could have gotten the answer without making. You don't understand my point.
Yeah.
You don't understand my point. My point is that there's no way you can get the answer without. Oh, just biology. You wanted the answer without making V2 sort of formula. That's what I'm making. Because some other time it may not work out like that. Two of us, some other time it may not work out. Mathematics is not like that. Sometimes it may not work out. The main thing is to know the point we are making here. Hope you can do it now. Now, when you enter my secret, anything that has, once you get to subject making a particular parameter or quantity, the sort of formula, I'll call you to do it for us. See, what did you solve? What do you want? Even a lawyer, so. But have you created a mistake now? Do you know?
Yes.
Is that what you got?
Yes.
It's not true. You just wrote it now.
That
Success, is that what you got?
I'll stop this before you stop your own.
Are you sure?
Yes.
Okay. So now let's go to the next question. In fact, what I will do now, I will see your work before I will check the I saw. Let me know those that are following me. What did you get? Success.
I did not get any answer.
Okay, you didn't get any answer. Wow. Okay,
That
this
one.
one, sorry. This one, we have not discussed this in class. Okay, please put asterisk there. We'll say when we go into Adiga's what, we look at it. That one they say that PV is equal to what? N what? RT. Okay. When we get to this point, we'll now solve this one. For now, just put what? Asterisk here. Okay. So let's leave it. Now this one, who solved the last one? Okay. What is the answer?
See the question.
Okay, what is the answer, Chine?
That liquid state.
Tomato bomb? No, I don't want tomato bomb here. Give me answer with reasons. Oh yeah.
Okay, liquid state.
Why?
First, a sample X, solid at room temperature, was melted,
Okay.
heated to a temperature of 358 Kelvin, and
Okay.
allowed to cool. So that's I know put it.
You don't put what?
The thing is both right.
From the question.
Yes.
So you got you give us the wrong question on the board.
No, it's not in that diagram. The thing is both.
That one, you didn't even see the end.
Okay, no, let me put it. Here is O. Here is P. Here is Q. Okay, you put R, right? Or your answer, huh?
That thing at room temperature, when it's melted, at that I don't know.
Who knows it? Answer is what? Liquid. Okay, but you don't know you don't know the reason.
Because according to the technical question on this thing, the answer is liquid now. Because something at room temperature cannot go back to solid, and it cannot be a gas.
Okay, you're saying liquid, but the reason is somehow. Oh yeah. Can't see what is the answer. With reason. If you don't know, you say you don't know. Let me go.
I'm not even ready.
I read it now. I read it and tell me fast. No time. You don't know. Jude. Oh yeah. What's the answer? Okay, you are still even. Is that writing the question? Okay, now. Oh yeah, try. Look at the question. Tell us. No idea. I should wait. I'm gonna go now. You go check one.
I just saw that because I want that formula, I forgot it.
Don't worry. No, you can talk to your own, but in this class, I will teach you if I go into it. Don't worry. Uh-huh. What was the answer? No idea. So after wasting our time, you tell me no idea. Jude. Okay, now let's look at the question. The question says a sample X. I'm talking, you are writing. Just look up. A sample X, solid at room temperature. So at room temperature is what? A solid. Was melted by heating it to what? A temperature of what? 385 Kelvin. In degrees Celsius, 385 Kelvin is how many degrees Celsius? 385 Kelvin is how many degrees Celsius?
It's minus.
Do it now and tell me. 258 minus 273. That should give us That should give us
It's fine.
85 what degrees. So room temperature is how many? How much degrees Celsius? Average, right? 25 degrees Celsius. So it was increased from 25 degrees Celsius to what? Can you say it with us? I'm explaining something now. You are busy. Please, I want your attention here, please. 25, it was moved from 25 degrees Celsius to what? 85 degrees Celsius. That's why it melted. It was at room temperature, solid at room temperature. When heated to 85 degrees Celsius, it's now what? It turned to what? It melted, right? After melting, it is allowed to cool as shown in this figure. Now, the section OP suggests that X is in dash. This section OP suggests that X is in dash. Here at O, right? At O, look at the temperature it was heated to is 358, 358 watts. 358 watts. Kelvin. Look at it here. See it here, 358. And at the 358 now, it has melted, right? In liquid state, right? Molten from a liquid state, right? Now, from this, there was a drop in temperature. From this 358, it came down to roughly 340 something. True of us. Decrease. Remember the kinetic theory of matter. Remember, when temperature comes down, the average kinetic energy of the what? Molecules will do what? Go down. True of us. They will slow down. True of us. Then they will now, if you move from here to here, it remains at what? The temperature remains constant here, right? Are we together? Are we together? The temperature remains what? Constant here. Even if you are, the time is increasing, the temperature remains what? Constant here. Now, for us to understand this thing, I want us to look at, let us interpret this whole thing first before we can go to sections. I want to use this thing to teach us something. Okay? Remember what we talked about latent heat, right? Remember what we talked about hidden heat. Can you remember? Hidden what? Heat. That when the temperature is constant, let's assume even if you are heating this thing, let's assume you are heating it. Let's assume the temperature is what? Increasing, for example, now. From here, you get to this point, even if you are adding more heat, the temperature remains what? Constant. This temperature is there to do what? Break the intermolecular what? Forces, holding the solid what? Holding the solid what? Together. Are we together? Holding it what? Together. It will melt. At this point, this is not, the heat applied here is not seen in the temperature scale. Am I communicating? Because it's there to do what? Break down the intermolecular. When the intermolecular forces are being broken down now, if you get to this level, it will do what? Turn to what? Liquid. Am I communicating? It will do what? Turn to what? Liquid. I just changed this upside down to use it to explain what I mean by latent heat. Okay? Now, if this is solid, you heat it, it will increase. Get to this point, more heat is used to break down the forces. Okay? When they are done breaking down, at this point, it will turn to what? Liquid. Okay? At this point, it will turn to what? Liquid. Now, if you keep heating again, if you keep heating, the temperature will be increasing again. When you get to the boiling point, if you get to a particular point, the heat again that we apply, we use to break down the many intermolecular forces that will release the liquid molecules to become what? Gaseous what? Molecule. And they will start, and it will now do what? Become what? Gas. And whether you trace from here to here and trace from here to here, it still points at what? Liquid. True of us. I will remove this. solid state, I'll remove solid states. I'll remove what? I'll remove what? Gaseous what? States. Those ones are out of the game. Okay? But remember what the question says. That at room temperature, I've used this now to describe the entire thing that happens in heating and cooling generally. Now let me answer the question, okay? Now look at it. Now look at it. Now let us now answer the question based on what is here. The question says a sample X solid at room temperature. Room temperature is what? 25 degrees what? Celsius, right? 25 degrees what? Celsius. 25 degrees plus 273 is what? What Kelvin? This thing is not complete. Okay, no problem. It's okay. It's okay. It's okay. It's okay. Now, this thing they will draw. A lot of things may not be exactly how it is. Okay, it's what 2 what 98. So is that melted by heating to a temperature of what 358 and are allowed to cool as shown in what OPQR. So they didn't tell us. If you check, had it been there's something like 298 here, you see that it can trace from here, but they are not like 298. They just told us from where it started what cooling. Okay, so if it was 358, it cooled to this point. It cools to this point. At this point now, what happens here? Is this liquid or solid liquid? Is it liquid? Look at it critically. Is it actually liquid? Is it here that should be liquid or here? Here. Is it solid liquid or is it liquid? Remember, it will still get to this point before it now drop to tell it to what? Here, what happens here? This P, is it liquid or solid liquid?
Like this device is liquid.
Tell me. I will too.
Because that according to what you say, sit at room temperature which is 25 degrees. So that was melted. Heated at the temperature of more than. So I don't think
here melted. Good. It was heated here as what? What is the state here? Is it liquid or solid? It's liquid, right? Good. It cooled to this place. Now the big question is this: here and here, which one is liquid and which one is solid liquid? I follow. Here is it liquid or solid liquid? Here is it liquid or solid liquid?
I think I will be solid
Eba abogene.
liquid.
Liquid. Eba abogene.
Solid liquid.
You become solid.
Going down.
You become solid.
Yes, now.
I like that. Here is what? Liquid. Here is what? Solid liquid. Because at this point now, more intermolecular bond is being formed here. True or false? At this point is what? Solid liquid. When you now go down, it becomes what? Solid completely. Are we together? So here is still liquid. Because this just a drop in temperature. It's still what? Liquid. But if it passes through this hidden heat, then it becomes what? Solid liquid, then solid. Here is liquid. Even though they didn't indicate whether it has gone to, it's liquid. Liquid. Solid, liquid, okay? Solid liquid and what? Solid. So A is the what? Answer. I use this question to go back to what we have done on this what? Change of state, okay? I use this to describe, to remind ourselves of what? Change of what? State. Two of you are looking at me as if you are not following. You see? So what is no, I worry. No, I worry you because you paid, so I must worry. So tell me your issue.
The last time you explained that when you say your that is looking at
I want you to understand what I've for the past 10 minutes or few minutes. I've been trying to if I talk, if I trace it from this side, I will trace for this. I was trying to look up, see what I'm trying to do here. I was trying to explain this. Look up now. What is it? You're giving up? No, don't give up like that, please. Please don't give up like that, please. Look up. Can I see the board? Are you sure? Don't give up like that. No, don't do that. Just try to just look at what I'm trying to explain. All this while, if I'll trace it, if you trace it from here up, look up. If you trace from here up, you are melting. Hope you know. Are you aware? If you trace from here up, you are doing what? Melting. True of us. If you trace from here down, you are what? Cooling. True of us. True of us. But I wanted to trace here. I checked where this is stopped. Had it been this is stopped at to before 298 degrees Celsius, I know that they wanted to trace it from here up. But I didn't see where it stopped here. That's why I now went back to where the first thing I did. So we're actually cooling, okay? From this one is from 358. Look at it here. So here now, at this point now, they didn't tell us that it turned to gas. So did they say so? That means it's still liquid. Here, this 358, they just heat it to 358 and it melted. So it's liquid at this point. Now, if you cool it to this point, you see that same what? Liquid. Now, everything here, the temperature drop, the drop in temperature doesn't show again here. The drop in heat, the loss of heat, they don't show again. Is within this hidden latent what? Heat. What this latent heat now, here now, this heat now, here, this heat here, hidden heat here now, this is where the whole thing of changing to solid takes place. True of us, because the molecule lost heat, that there's loss of heat, temperature went down, and because of loss of heat and decrease in temperature, there is the molecules will slow down. True of us. And if they slow down, the tendency of what? Coming together, two of us. All this happens here. So at the end of this long time of coming together, you now have a mixture of solid and liquid here. Because they were only liquid here. But because they have slowed down and they have come together within these minutes, they have come together. What we have is a mixture of what? Solid and what? Liquid. So now, if you this thing you are writing, after that, you said that you're confused here. It's a mixture of what? So at the end, this is what you see here. Further loss of heat, decrease in temperature, will now transform into what? Solid. Those small ones, those small liquid molecules that are still moving around, will come together more, two of us, and become what? Solid. So that's why I said that here is liquid, here is solid liquid, and here is what? Solid. Am I communicating? So loss of heat, the temperature coming down will make the molecules to do what? To slow down, and they come together more. And the intermolecular bond will what? Will reestablish, two of us, and that will make them to move from liquid to what? Solid state. Do you now understand why we say that place is liquid? Good. No, this thing took us time, but I think it's better. At least we have a kind of what is it called? Some people have forgotten what we discussed under this topic. Even see yourself, some people even forgot Boy's law. Boy's law we just did when. So the next thing we'll look at, what's time? No, it can't be 6 o'clock. When did we start? What time? Hey, come, wait. Tell me the truth. Do you watch this lecture at the end of? That's the problem. Perhaps you watch it. Do you know why? Because there are some things. See, you must not grab everything. People differ, okay? The rate of assimilation differ. There are people that immediately, as you are saying it, they have even grabbed it. But you that is still having issues, go back, watch. That's why I'm doing this thing. Oh. If not, I will just come here, teach and go my way. I keep this thing for record purposes. For tomorrow, I may not be there. Even you say may not be there. Somebody else may be benefiting from it. But now that we are here, you can also be benefiting from it. Am I communicating? It's true. Look at it now. Look at it. There are people that have this YouTube, but today then some of them for some of them are dead. Hope you know. But the valuable content they dish out to the world, the whole world is watching it. This thing you see me do here and upload, I'm not doing it for myself. Tomorrow I may go. What is there? YouTube will not close it down. Hope you know. The channel will remain there. But the powerful content, people that yet to be born will watching it. Unless YouTube closes down. So please take this in seriously. You that are here, if you save your data for something reasonable. If you don't have data, tell your parents, Daddy, I need data to watch these lectures. I have lectures to watch. Let me make up my mind. Let me understand. Let me assimilate what we are taught in class. Once they realize that it is for your academics, they will give you the data. But you know, most parents will feel that you want to use data to be doing nonsense, watching film and they going to Facebook. If you say that, they'll say, go and sit down. But when they realize that you truly use it for something meaningful, they give it to you because they want you to pass. Not only this course, there are other things you can learn from it. Am I communicating? And the fun part is it's not only my own self. If you Google anything, if you Google any topic in our YouTube, you see a lot of what content you can watch on that particular topic. So please take this in seriously. This is my own contribution to that pool of knowledge. All right. So I think we at this point I think we have done something. We have reviewed the first question. We could not do much that in our last class. In our next class, we go over to what? The next gas law. I want us to go over to Gerusha's law of combining volume. I wanted us to go to ideal gas equation, but there are some things that you will still get from Gerusha's law before you can go. There are some things you want to. I want to explain there. They take us to what? Gerusha's law, and even Avogadro's law. So because of that, I want us to do Gerusha's law. After Gerusha, no, sorry. The next one is what? Dalton's law of partial pressure. Good. After Dalton's law of partial pressure, we do Gerusha's law. After that, we do Avogadro's law. Before we now go to what? We now go to what? Ideal gas what? Equation. So once we are done with that, we'll now look at possibility of looking at rare gases. So people know that we have rare gases and ideal gases. Are you aware? But anyway, that one is a bit advanced. But it's okay. Any question? Any question? Okay. Then I want to go. And after that, okay, so we'll stop here. See you tomorrow. Sorry, tomorrow is Monday, right? Thursday is what? English language. All right.